At the end of this topic, you will be able to construct a perpendicular bisector to a given line segment, construct a perpendicular from the given point on the given line, construct a perpendicular line through a point not on the given line.
Now let us see how to construct a perpendicular bisector. Draw a line segment of length 7 cm and construct its perpendicular bisector. Here are the steps of construction. Draw a line segment AB of length 7 cm using a ruler. Take a compass and measure the radius as more than the half of AB. With A as center, draw arcs one above AB and other below AB. With B as center and same radius, draw two more arcs to cut the previously drawn arcs. Now, join the two intersecting points and name the line L. The line L is the required perpendicular bisector of AB. Let us construct a perpendicular from the given point on the given line. Here are the steps of construction. Draw a line L and mark a point P on the line. With P as center, draw a semicircle of convenient radius to meet L at A and B. With A as center, draw an arc of radius more than AP above P. Without changing the radius and B as center, draw another arc to cut the previous arc at Q. Join PQ. Thus, PQ is the required perpendicular. Let us construct a perpendicular line through a point which is not on the given line. Here are the steps of construction. Draw a line M and mark a point A that doesn't lie on the line. With A as center and draw an arc of radius more than the perpendicular distance from A to M to meet M at P and Q. With P as center, draw an arc of radius more than the previous radius below the line M. Without changing the radius and Q as center, draw another arc to cut the previous arc at B. Draw a line N by joining A and B. Thus, N is the required perpendicular line through A.
Special line segments within triangles. The line drawn perpendicular through the midpoint of a given line segment is called the perpendicular bisector of the line segment. The line which passes through the vertex of the triangle and is perpendicular to the opposite side is called the altitude of a triangle. In this topic, you have learnt to construct a perpendicular bisector to a given line segment, construct a perpendicular from the given point on the given line, construct a perpendicular line through a point not on the given line. At the end of this topic, you will be able to construct the circumcenter, construct the orthocentre.
Here is how we construct the circumcircle of a triangle. Steps for construction. First, draw perpendicular bisectors of any two sides, say AB and AC of the triangle, and let these intersect at O. Second, draw a circle with O as center and radius R, which is equal to OA equal to OB equal to OC. This is a required circumcircle of the triangle ABC.
Here, we shall learn about construction of circumcircle of a triangle. Construct the circumcircle for the triangle ABC such that AB is equal to 4 cm, BC is equal to 6 cm, and AC is equal to 6.5 cm. Also, find its circumcenter. Click on the steps of construction to view it.
Orthocentre of a triangle. The line which passes through the vertex of a triangle and is perpendicular to the opposite side is called altitude of the triangle. Since a triangle has 3 vertices, it also has 3 altitudes. The point of concurrency of the altitudes of a triangle is called the orthocenter of the triangle. Orthocenter is usually denoted by H. The orthocenter is not always inside the triangle. If the triangle is obtuse, it lies outside the triangle. For a right-angled triangle, the orthocenter lies at the midpoint of the hypotenuse. Construction of the orthocenter of a triangle. Here are the steps to construct the orthocenter of a triangle. Step 1. Draw the triangle ABC with the given measurements. Step 2. Set the compass width to the length of any side of the triangle. Step 3. With the compass on B, one end of that line, draw an arc across the opposite side. Label this point P. Step 4. Repeat for the other end of the line C. Label this point F. Step 5. Take radius more than half of BP. Step 6. With B as center, draw an arc with radius more than half of BP. Step 7. From B and P, draw two arcs that intersect, creating point Q. Step 8. Use a straight edge to draw a line from C to Q. The part of this line inside the triangle forms an altitude of the triangle. Step 9. Take more than half CF. Step 10. With C as center and more than half CF as radius, draw an arc. Step 11. With F as center and without changing the radius, draw an arc to cut the previous arc. Mark the point of intersection as E. Step 12. Using a ruler, join B and E. Hence, BG is another altitude for the triangle ABC. Step 13. The point of intersection of the altitudes is the orthocenter of the triangle. Denote this as I. In this topic, you have learnt the point of concurrency of the perpendicular bisectors is called the circumcenter of the circle. The point of concurrency of the altitudes of a triangle is called the orthocenter of the triangle.